So like I said, we're going to continue to grow off of this sequences and series. I'm going to explain what a series is today. So I'm going to open up that part of our notes. And in our last class, this was the last thing we did. We were talking about sigma notation. And so sigma notation, this thing just means we're going to add a string of numbers together. And so how do we generate this string of numbers we're going to add together? Well, what we do is we take whatever number that is and we plug it in and get an answer. And then we keep plugging in integers up until we get this number and plug it in and get an answer. And that tells us how many terms we have. Okay. So we actually would have 7 terms. I know because we'd have 1, 2, 3, 4, 5, 6, and 7. Okay. So we'd have 7 terms that we would be adding together. So in this case, I'm going to take this a step further. And I'm going to ask you a similar question, but it's going to look harder, but I'm going to try and make it easier by applying a little math to it. And this is going to be an arithmetic series. Arithmetic just means that we're going up by the same amount each time. But the term series just means we're going to add things together. I didn't use specifically that term before, but kind of that sigma thing means we're adding things together. That's what a series means also. So this would be an example of a question that we might have. If we want to find the summation of this. Let's say we had a summation, and on the bottom, I'm going to put n equals 4. On the top, I'm going to put 50. And my equation is 2n plus 3. So again, a lot of this goes back to, do we understand what is being asked? You know, this is our question. It's saying, this part tells us we're going to add them all up. This is the first number we're going to plug in, 4, and then we're going to plug in 5, and then we're going to plug in 6 and 7 and 8, 9, 10, all the way up to 50. Now, if we do that, that's going to be a ton of numbers, okay? And I'm going to write down just a couple of the first ones, but if I plug 4 in, 2 times 4 is 8, plus 3 is 11. Then I'm going to plug in 5. 2 times 5 is 10, plus 3 is 13. Then I'm going to plug in 6. 2 times 6 is 12, plus 3 is 15. And I don't want to keep doing that all the way up to 50. So I have a formula for an arithmetic series. I'm going to actually move this down a little bit so I could sneak my formula right under our. Get that ugly. All right. So our formula for an arithmetic series is this. S sub n is equal to n times a sub 1 plus a sub n divided by 2. So like I highlighted before, I'm going to highlight this one. This is an important one that we're going to use quite a bit. So we use that formula to find the sum of an arithmetic series, which is exactly what we're trying to do. So I'm going to use this formula down here to solve this problem. So I want to find the sum. So I'm going to do n Now remember, n means how many terms are we adding together? Well, I'm going to start with the number 4, and then the number 5, and then the number 6, and then number 7, and I'm going to do that all the way up to 50. And so there would be then, might seem like 46, but it's actually 47 terms because we're going to plug in 4 first. Okay, and I got that kind of subtracting those two and adding 1. There would be 47 numbers in this string. So that's our n value. Times a sub 1 means our first value, which is 11. Plus a sub n. A sub n is our 50th term, which is way down here. We didn't figure that out yet. But all I need to do is plug in 50 to get that term. So 2 times 50 is 100 plus 3 is going to be like our last term. Then divided by 2. Okay, so again, just to show you where those numbers came from, n is the number of terms which I got by just doing 50 minus 4 and plus 1. Okay, so that gave us the 47. So n was the number of terms. A sub 1 is the first term, is 11. A sub n is the last term, which was 103. And remember, we got that by plugging 50 into the equation. And then it's always divided by 2. So now I'm just going to plug that into my calculator. So 47 times 11 plus 103 divided by 2. Come on, calculator. So 47 times 11 plus 103. Now I can do a couple things. If I'm going to make that as a fraction, I have to divide the whole thing by 2. Or if you're using a different kind of calculator, remember you have to put the whole top or numerator in parentheses. But I get 2,679. That is our answer. Okay, so the big takeaway is if we're going to find the sum of an arithmetic series, we're going to use that formula, and we just have to figure out what n is, and a sub 1 is usually easy. That one, a sub n, we just have to get by plugging the term in. All right, let me do one more. We'll do one more together, and then we'll do I'm sorry, I'll do one more, and then we'll do a couple of them together, okay? So let's find the summation. Of this. So I have a sigma from n equals 3 to 65. And 6n plus 4 is my equation. All right, so that's how the question will be worded. So what we need to do then is, let's get a visual for the string of numbers we're talking about. So we first would plug in 3. 6 times 3 is 18, plus 4 is 22. And then we plug in 4. 6 times 4 is 24, plus 4 is 28. And we will plug in 5, get 34. And you don't even have to write all those down. I'm just trying to give you an idea of what it looks like. We definitely need the first term. We definitely need the last term. So to get the last term, I'm going to take 65 and plug it in there. So 65 times 6 plus 4, looks like a good calculator problem. 65 times 6 plus 4 is 394. So we're going to use our formula, which is going to be adding all these things together. Now remember this formula up here for an arithmetic series. So here we go. First, we want to do our n. To get n, it's going to be 65 minus 3, which is 62, but plus 1. So there's actually 63 terms. Okay, times our first term, which was 22, plus our last term, which was 394. And then I'll divide it by 2. So to the calculators we go. 63 times 22 plus 394. Is that right? I'll divide it by 2. And there is our sum. So it is 13,104. So luckily we have this formula. We don't have to figure out, all 63 of those numbers and add them all up. That would take a whole lot of time. All right, I'm going to have you guys do a couple in class kick in just a second on your own. Are there any questions before I have you do that? All right, let's go over that second one on the class kick here. So we want to write this in sigma notation. So I have my sigma. And I know that there are 1, 2, 3, 4, 5 terms. So n is going to go from 1 to 5. And then my formula is a sub 1, which is the first term, plus n minus 1 times d, and d is 10 because it's going up 10 each time. All right, any questions on that one? No? All right, well then one more then. I'm going to do on the third page now. This is going back to kind of where we started with this. The first 3 terms of the sequence are given. We want to find the 30th term. So this is a sequence. So in our sequence, it's arithmetic, which this is. We do a sub n is equal to a sub 1 plus n minus 1 times d. And we're trying to find the 30th term. So our a sub 1 is 156. Plus our n is 30 now because it's the 30th term. And our d is going to be -3 because it goes down 3 and down 3 and down 3. So I'll plug that into my calculator. So 156 plus 29 times -3. I have negative 13,572. That didn't sound right. I missed a plus sign there. Sorry, guys. It's 156 plus 29 times negative 3. Quarter, 69. How did I get what? Negative 3 is the D value. And that's because it went down 3 and down 3. Okay, so it's how much it's going up or down. It's how much each term is changing each time. So they're going down 3. Now for the second problem, I'm going to have you guys try the second one. But this is geometric. So remember our formula for geometric is a sub n is equal to a sub 1 times r to the n minus 1. So would you guys try and find the 10th term? So 10 will be your n. You have to find your r. Remember, you can do that by doing the second term divided by the first term. So give that a shot, and we'll go over that in just a second. 1 divided by the first one. All right, so let's take a look at this problem. So to find the 10th term, first, this is geometric and not arithmetic. And the reason it's geometric is because, remember in our previous problem, we subtracted 3 and then subtracted 3 and so on. In this problem, if I subtracted 6 and then I subtract 6 again, it doesn't work out. Okay, so it's not arithmetic, it is geometric. And so if it's geometric, we find r instead of d. I'll show you how to do that in just a second. But we do a sub 1 is our first term, which is 18, times our r value. To get r, you can always take any number divided by the 1 in front of it. So 12 divided by 18, and then reduce it. Or 8 divided by 12, you get the same thing and reduce it. You will always get 2/3. So our r value is 2/3. Our n is 10, because we're finding the 10th term, so 10 minus 1. So now I'm just going to plug that in. So it's going to be 18 times 2/3 to the 9th. I'm going to get a decimal approximation. I think delta asks us to round that to the nearest thousand. So it's 0.468. Yes, what's up? Oh, okay. Yeah, and just make sure that you have here, remember that that's 2/3 and not 3/2. Okay, it's always like the second one divided by the first one.
Mr. O'Connor, isn't it negative?
Let me see. Is what negative? The r value?
Yeah.
No, it's not negative. It is going down, but that's because this is less than 1. See, if it's geometric, that means we're multiplying by 2/3, which of course is going to make it lesser, and then multiplying by 2/3. Now remember, if that was negative, then every other term would be negative, right? It would go positive, negative, if we were multiplying. So it is positive 2/3 for the r value. Good question. And you had another question? Anything else, guys?